So here we are talking about standard 1.2, finding the height of various points on a wheel in relation to the ground. So let's determine some information about our wheel first. Our wheel is going to have a diameter of 50 inches. And let's say that one rotation is going to take us 30 seconds. And now let's find the height of the gum at 11.25 seconds. And the first thing we need to do is figure out where 11.25 seconds is on our wheel. And so let's take 30 seconds, which is one full rotation, and let's divide that into 4 so we get at least what time we are at every quarter of a circle around. So if we take 30 divided by 4, we get 7.5. And so we can count by 7.5 seconds for each quarter of a circle to get all the way around. Okay. So 0 seconds, and then we're going around, so it's 7.5 seconds, and then add another 7.5, so it's now 15 seconds, add another 7.5, and it's 22.5 seconds, add another 7.5, and we're down to 30 seconds. Now we know 11.25 seconds is somewhere between 7.5 and 15. And we have to figure out exactly where it is because that's going to help us determine what kind of triangle we have to include in our picture. Is it a 30, 60, 90? Is it a 45, 45, 90? Well, let's consider some radii, or diameters rather, here. Okay. And right now with these diameters, we've divided our circle into fourths, right? 30 divided by 4. If we were to divide these fourths in half again, we would have eighths. So let's figure out how many seconds we're traveling if we go around 1/8 of our wheel. So if we take 30 and divide it by 8, we get 3.75. So again, this is when we divide it by fourths. So these are 1/4, which count every 90 degrees. And up here, if we divide it by eighth, we're going 1/8 of your circle, which is every 45 degrees. Okay? So 3.57 seconds if we're going by eighths. So again, we're starting at 0, add 3.75. Now we're here. Add another 3.75. We're now at 7.5. Add another 3.75. We are now at 11.25, which is the time we want, but let's just keep on going so we get these times. Add another 3.75, we get to 15. Add another 3.75, and now we're at 18.75. Add another 3.75, we're at 22.5. Add another 3.75, we're at 26.25. And if we add another 3.75, we should be to 30 seconds, and we are. Okay. So now we can see that 11.25 is a value that we get when we're going by eighths. And each eighth of a circle, we are traveling 45 degrees. And so when we build in our triangle, and the hypotenuse of the triangle is going to be the radius of the circle, when we build in our triangle, we know that the triangle is a 45, 45, 90. And that's because, again, we divided our circle into eighths, and each eighth is 45 degrees. Now our job is to find the height of the gum at 11.25 seconds. So this green blob here is our gum, and we're really trying to find the length of that green segment. Now if I highlight part of that green segment, we can see that it's the same length as our radius. We really have a rectangle down here, and we know that the radius, let's go back, what did we just say? The radius is 25 inches because the diameter is 50 inches. So we are going to label our radius with 25 inches. And we need to then find this yellow segment, because when we do that, the yellow plus this blue will add up to the entire height of the gum to the ground. So we look at this yellow segment, which is a side of our 45, 45, 90 triangle, and we know that the radius of the triangle is 25. So we can label 25 here on the radius of our circle, which is also the hypotenuse of the triangle. Now going back to standard 1.1, 25 is on the x root 2 side of our triangle. So we can take the equation 25 equals x root 2 and solve for x. We're going to divide both sides by root 2. And we get x equals 25 over root 2. Excuse me. And then we need to rationalize, because the root in the denominator tells us we're not fully simplified. So we're going to multiply numerator and denominator by root 2. We get 25 root 2 over 2. And because 25 and 2 are compatible, both of them are outside of the root symbol, you can divide and get 12.5 root 2 as the leg of our triangle. It's x, right? And each leg is x. So this is 12.5 root 2. Don't worry that there is a root 2 attached to it, even though it's a leg. That is completely okay. All right, so now we're trying to find the height of the gum from the ground. So it's going to be this 12.5 root 2 plus this 25. And so we can say the height of the gum is 12.5 root 2 plus 25 inches from the ground. And we can leave our answer in that form, or we can get a decimal equivalent. We don't want to add the 12.5 and the 25 together. They're not compatible because the 12.5 has a root 2 and the 25 doesn't. Now, if we wanted to find the height of the gum at 18.75 seconds, you can see it's going to be the same situation, right? We have another 45, 45, 90 triangle there. We have 12.5 root 2 plus another 25. So at 18.5 seconds, it's going to be the same. Suppose we wanted to find the height of the gum at 3.75 seconds. So now let's try finding the height at 3.75 seconds. And we can see again that that lands on one of our eighths. And so we can continue to use this diagram, and we know we have 45, 45, 90 degree triangles in there as well. So at 3.5 seconds, I'm just going to erase some of this stuff here that might clutter our picture up. Here's our gum. We want to find that particular height. And again, we know that that is at 3.75 seconds, right? So maybe we'll leave the number there. Okay, so we need to find the length of that segment. Now, if we again draw a triangle, and keep in mind that we're going to draw from the gum to the center, and that's the radius of the circle as well. And then we can use that as a hypotenuse of our triangle. Again, this is going to be a 45, 45, 90 degree triangle because we were counting by eighths around our circle. So that's 45, 45, and 90. And it's the same triangle. This is 25. This is 12.5 root 2, as is the other leg. But now we're really just trying to find this little segment down here. From 3.75 inches to the ground. So let me erase the current blue highlighting. Let's see if I can do that. And let's see what we're really trying to find. We're trying to find the length of that yellow segment, which is the same as the length of the green. Now note that our radius is 25. So this whole segment is 25. And part of it is 12.5 root 2, which is the side of the triangle. So if we want to find this yellow piece, we can subtract from this whole radius of 25 inches this piece, which is 12.5 root 2, and we'll be left with the remaining piece. So the height at 3.75 seconds is 25 minus 12.5 root 2 inches. And you can see, because of the symmetry of the wheel, that at 26.25 seconds it would be the same. A couple of other heights that are pretty straightforward to find here would be at our quarter turns. So at 0 seconds, obviously the height is 0. At 7.5 seconds, it's just the radius. So the height is just straight up 25 inches. Here at 15 seconds, you can see the height is the diameter, which is 50 inches. Here at 22.5 seconds, again, we're dealing with the radius, so the height is 25 inches. And then we're back to the ground again. But now suppose we have a different height. So let's try to find the height of the gum where the gum doesn't land on one of these quarter circles, or eighth of a circle, rather. All right, so now we're going to try to find the height of the gum at 20